You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine you are sitting at your desk, coffee in hand, and suddenly your computer cursor starts moving completely on its own.
Oh, wow.
Yeah, it is clicking through menus, opening your web browser, and just casually finishing up your spreadsheet. And while you are staring at that, doing a massive double take, you glance out your office window and see a delivery truck driving past, carrying a payload of actual antimatter.
Right, as you do.
Exactly. Oh, and meanwhile, a billionaire is pouring concrete for a massive custom chip factory designed entirely to prepare humanity for Mars.
I mean, that sounds like the opening montage of a sci-fi film where everything is about to go terribly wrong.
It really does. But it is not sci-fi. It is exactly what we are going to look under the hood of right now. I am the vocal technologist, your tech-savvy mate who spends way too much time reading the fine print so you do not have to.
Which is a heavy burden, let us be honest.
Too right it is. But my mission here is simple. I want to cut through the jargon and equip you, the smart but time-poor listener, with the exact knowledge you need to understand where technology is actually heading.
And the overarching theme connecting all these wild developments is that the boundary between our digital systems and physical reality is, well, it is collapsing entirely.
Spot on. We are building the nervous system and the physical body of a new era simultaneously.
Yes.
So we are going to unpack how AI is moving from just chatting with us to taking physical control of our screens. We will explore the brutal reality of software learning to maintain itself, the massive physical infrastructure required to run it all, and finally, the literal space hardware being built to expand this tech empire off-world.
It is a massive scope.
It is. So, before we get into rockets and antimatter, we have to start right where you were sitting looking at your screen. Because AI is transitioning from a passive chatbot into an active participant. Anthropic has given their model, Claude, the ability to control a computer.
Which is a massive leap.
Yeah, it can physically move your cursor, type, use web browsers, and operate your file systems.
The technical hurdle required to make that happen is just immense. Because, traditional AI sits in a walled garden waiting for text prompts. But allowing an AI to navigate a graphical user interface requires spatial reasoning. It has to look at a screen, take what is essentially a screenshot, identify the exact pixels that represent a submit button, calculate the X and Y coordinates, and then execute a sequence of motor commands to move the mouse and click it.
But obviously, you do not want an AI just clicking around your operating system unchecked.
Definitely not.
So they've introduced something called auto mode for Claude Code. It features a separate classifier model that autonomously makes permission decisions.
Like a safeguard.
Exactly. It acts as a safety valve, constantly reviewing the conversation and blocking actions that escalate beyond the task scope or just seem unsafe, which makes complete sense.
It really does.
Handing Claude the keys to your computer is a bit like handing the steering wheel of your digital life to a highly capable teenager. You absolutely need those classifier safeguards in place so it does not accidentally delete your hard drive while trying to optimize your inbox.
Yeah, and the fascinating part is that the engineers actually had to build diagnostic tools just to peer inside the neural network and understand how it thinks.
Wait, really? They did not know.
No, when they traced Claude's internal computations, they discovered that the model is developing its own unexpected strategies. They did not explicitly program how it should solve problems.
Oh, wow.
It was trained on massive data sets, and through that training, it developed emergent reasoning pathways to figure out how to navigate operating systems entirely on its own.
That is wild. The machine is literally inventing its own logic to solve spatial problems. And it is not just Anthropic pushing these boundaries. Apple is testing a standalone Siri app for an upcoming iOS update.
Right, transforming it completely.
Yeah, it will take Siri from a basic voice assistant into a system-wide AI agent. And to pull this off, they are using Google Gemini models running in Apple data centers to train their own smaller on-device model.
Which is a very clever move.
On top of that, they're even going to allow rival AI assistants onto the platform.
Apple's strategy of using Gemini's reasoning to train smaller models is a brilliant technical maneuver.
Right.
In machine learning, this process is called distillation.
Okay.
You take a massive, highly capable model running on giant server farms, and you use it to teach a smaller, more efficient model.
Hold on. Let us break that down for a second. How exactly does a giant model teach a tiny one? I mean, is it just copying the database over?
Not quite. You cannot fit the entire knowledge of the internet onto an iPhone.
Fair point.
Instead, you have the massive model generate millions of step-by-step examples of how to reason through complex problems. The smaller model trains on those examples.
I see.
It is not memorizing the facts, it is learning the methodology of thinking. That allows Apple to distill vast intelligence into a compact version that runs entirely on your phone's local processor.
Which preserves your privacy because your data does not have to leave the device.
Exactly, while still scaling up the AI capabilities significantly.
Using the giant to tutor the local apprentice on how to think rather than what to think. I love it. And speaking of corporate giants, Mark Zuckerberg is actively building a CEO agent to help him run Meta.
Of course he is.
He envisions a future where everyone has a personal AI agent, and his own agent is currently helping him surface information faster. But here is the detail that really got me. Meta employees now have their own AI usage factored into their performance reviews.
It signals a profound shift in corporate culture.
You reckon?
Absolutely. Fluency with AI is no longer a peripheral skill or a neat party trick. It is being treated as a core competency required to do your job, and management is enforcing adoption straight from the top down.
I mean, tying your bonus to how much you chat with a bot, because apparently that is where we are now.
Right.
It is genuinely amusing, but also a bit confronting.
It is a wake-up call for a lot of people.
Yeah, if AI is clicking our screens and helping CEOs run entire companies, it is definitely coming for the back-end operations. We are moving from the front-end user experience to how the software industry is essentially cannibalizing its own manual labor. Code is starting to write code.
And that changes everything, because software businesses are living systems that require constant maintenance, verification, and refinement. Historically, that required armies of human engineers monitoring dashboards and fixing bugs.
But look at what Ramp is doing. They have built an agentic system to maintain their internal sheets and back-end processes.
Right.
This system continuously monitors production, triages alerts, and actually proposes fixes without human intervention. Now, human engineers still review the code before it is merged, but the heavy lifting of diagnosis and drafting the solution is fully automated.
That is made possible by what the industry calls durable execution. Agents are running on fault-tolerant orchestration runtimes, making exhaustive monitoring feasible at a scale that, well, human teams simply could not manage.
Wait. I promise the listeners no jargon. What on earth is a fault-tolerant orchestration runtime? Let's translate that into plain English. Are we just talking about a system that refuses to crash even if part of it breaks?
Fair point, sorry. Basically, normal software is forgetful. If a script hits an error or a server blips, it crashes, and it forgets what it was doing.
Right.
A fault-tolerant orchestration runtime saves its state every single millisecond. If it crashes, it wakes up and resumes exactly where it left off.
Oh, that is clever.
Because these agents possess durable execution, meaning they never lose their place, they can monitor server logs 24 hours a day without fatigue. Humans get tired watching logs. Agents do not.
It is like running a restaurant where the kitchen appliances not only cook the food perfectly every time, but they also monitor their own power usage and order their own spare parts the second they detect a slight drop in voltage, all without the chef ever knowing.
That is a brilliant analogy.
And we are seeing similar moves at Stripe. They have a new tool called Stripe Projects that allows developers to provision real, production-ready services directly from the terminal. You do not even have to leave your command line to set up complex infrastructure or sync agent-ready credentials.
Both Ramp and Stripe are demonstrating a shift away from tribal knowledge.
Tribal knowledge.
Yeah, in any engineering team, there are unwritten rules. There is historical context, like knowing that a specific piece of legacy code always breaks on leap years, which is passed down orally from senior developers to juniors.
Oh, yeah, the guy who knows the system because he built it 10 years ago.
Exactly.
Yeah.
Companies are now aggressively extracting that essence into AI models. The goal is to no longer rely on fragile human memory. If the agent knows the environment and the code base perfectly, the business is no longer vulnerable when a senior engineer decides to leave.
Which brings up the absolutely brutal reality of what that extraction looks like in practice. Snowflake has reduced its workforce by 400 people, specifically targeting their technical writers.
Yes, I saw this.
And how they went about it is staggering. Management Screen recorded the writers working on documentation sessions for 8 months. They used those exact recordings to build training data sets for an AI pipeline.
Wow.
Then they made those senior writers spend their final 6 weeks transferring their knowledge to the AI system before letting them go, which, yeah, is exactly as terrifying as it sounds. You are literally training the machine that is actively taking your desk.
It is genuinely bleak for the individuals involved. You're watching your expertise being fed into a machine.
It is brutal.
But from the boardroom's perspective, they're looking at public markets demanding massive, true operating margins. CEOs are under immense pressure to rebuild their companies for high profitability rather than just growth at all costs.
Right.
By automating the documentation pipeline, Snowflake Management claims they achieved 300% efficiency gains.
The sheer psychological toll of spending your last 6 weeks teaching a bot how to mimic your exact writing style is wild. It is the ultimate automation of engineering and documentation.
It really is.
But if we are paving over human jobs with all these brilliant, self-maintaining digital agents, we run into a physical problem. The agents clicking our mice and writing our docs do not just live in the ether.
No, they require massive physical infrastructure. Things are getting properly weird out in the real world to support them.
For instance, Tesla and SpaceX are teaming up to build a massive terafab chip factory in Texas. This facility is going to support AI, space settlements, and Optimus humanoid robots.
Taking on a chip fabrication plant is a colossal undertaking. The facilities are incredibly expensive to build and require extreme precision.
Yeah.
Usually, tech companies outsource this to massive foundries in Asia. But by bringing it in-house, Tesla and SpaceX can run a rapid feedback loop and achieve super high production rates for highly specialized silicon.
But why do they need such specialized silicon? I mean, cannot they just buy standard chips off the shelf?
Standard chips are designed for data centers with perfect climate control. Tesla and SpaceX need chips optimized for the harsh radiation environments of space, where cosmic rays can literally flip the bits in a processor and cause catastrophic errors.
Oh, wow.
They also need chips capable of processing complex physical movements for robots in real time.
Because the digital brains we were just talking about now demand physical bodies, which explains why Amazon has acquired Fauna Robotics, a startup that builds approachable bipedal humanoid robots.
Right.
They have a model named Sprout.
The operative word there is approachable. If you are going to deploy bipedal robots into warehouses or eventually consumer environments, human psychology becomes a major factor.
That makes perfect sense.
You need highly specialized silicon from places like that terafab to process the immense sensory data required for a robot to move safely around humans. If a heavy metal machine moves unpredictably, humans panic. The digital mind is finally getting a physical shell that can interact with our environment seamlessly.
Okay, so we have custom chip factories and approachable humanoids. But let us talk about the infrastructure required for really high-end physics. Scientists successfully transported antiprotons on a 10-kilometer drive around their campus in a truck.
That's right.
They used a special ion track to solve the massive challenge of antimatter annihilating the second it comes into contact with regular matter. But hang on, we are casually transporting antimatter in a truck. What happens if there is a pothole? Seriously, the real-world impact of playing with explosive physics in a delivery vehicle feels like a massive gamble.
I completely understand the skepticism, but the engineering behind this is incredibly rigorous. The scientists developed an advanced ion trap that suspends the antiprotons in an absolute vacuum using electromagnetic field.
So the antimatter is just hovering in the middle of a thermos?
Essentially, yes. If antimatter touches the atomic walls of a standard container, it triggers annihilation, releasing a massive burst of energetic particles. The electromagnetic fields prevent it from ever touching the sides.
That is insane.
The reason this physical transport is so crucial is that the main CERN facility is incredibly noisy from an electromagnetic perspective. There's too much interference from all the other experiments. To study antimatter with extreme precision, to understand the fundamental symmetry of the universe, you have to move it to quieter, isolated facilities. The ion trap truck makes that physical transfer possible.
So we have literal antimatter cruising down the road in a high-tech thermos so scientists can get some peace and quiet to study it. It is mind-blowing when you step back and look at the physical toll of all this innovation. We are reshaping the actual Earth, transporting exotic physics and building mega factories to support our digital ambitions.
And once Earth becomes constrained by real estate and power grid limitations, the logical expansion for this physical infrastructure is orbit and beyond.
Right. If we are paving over Texas with terafabs just to keep our current AI running, Silicon Valley has to look up. SpaceX is preparing for a massive initial public offering targeted to raise between $40 billion and $80 billion. But they are using an incredibly unconventional playbook to get investors on board.
They are not doing the usual pitch decks, are they?
No, instead of standard boardroom pitch decks, they are taking fund managers on factory tours and making them watch live rocket launches.
It is a highly sensory approach to capital raising. By letting investors feel the physical rumble of a rocket launch in their chest and see the immense scale of the manufacturing floor with their own eyes, you bypass purely analytical financial models.
You make them feel it.
Exactly. You tap into raw human ambition and awe. It is a very effective way to generate the massive capital required for interplanetary infrastructure.
And that space infrastructure is shifting fast.
Yeah.
NASA is actually pausing its lunar space station project to focus on building a surface base on the moon. But they are not just scrapping the station parts they already built.
No, they have bigger plans.
Yeah, they plan to repurpose the core of the Gateway Station into a nuclear propulsion demo for a Mars mission. We are taking the core of a space station, making it nuclear, and pointing it at Mars. Let us pull apart the mechanism there. How is a nuclear rocket different from the massive chemical rockets we see launching today?
Well, chemical rockets rely on combustion. They are essentially controlled explosions throwing fire out the back to generate thrust. They are incredibly heavy and relatively slow.
Right.
Nuclear thermal propulsion, on the other hand, uses a nuclear fission reactor to heat a liquid propellant, usually hydrogen, to extreme temperatures. The hydrogen rapidly expands and blasts out the nozzle, creating thrust that is roughly twice as efficient as chemical engines.
So it is basically a nuclear-powered kettle boiling hydrogen into space.
That is a great way to visualize it. And this transition is absolutely essential if we want to move heavy payloads across the solar system. It drastically reduces travel time to Mars from around 7 months to just a few weeks.
Which changes the math entirely.
Exactly. That speed is vital because it limits the amount of time astronauts are exposed to dangerous cosmic radiation in deep space, making sustaining a settlement viable. But to power all of this, and to power the massive AI models we discussed earlier, we need unprecedented amounts of energy. People are seriously proposing orbital data centers.
Right. The idea of floating server farms in space to capture abundant, unfiltered solar energy. But is the night sky not crowded enough without adding flying server farms that block out the stars? Astronomers are already complaining about satellite constellations ruining observations. If we start putting entire data centers in low Earth orbit, we are basically paving over the Milky Way.
Your concern about astronomical visibility is entirely valid and is a major point of contention in the scientific community. The light pollution and radio interference from mega constellations are already interfering with deep space observation.
It is a real problem.
We have to balance technological expansion with our ability to actually study the universe. However, current economic models show orbital data centers are highly unviable anyway. Replicating the output of just one large terrestrial data center would require launching hundreds of massive satellites.
Oh, wow.
The logistics, the launch costs, and the sheer expense of building complex computing architecture in the vacuum of space are staggering.
We would need an armada of rockets just to run ChatGPT in orbit.
Exactly. And there is another, deeper limitation to endlessly scaling complex systems, whether we are putting them in space, generating AI code, or running biology in a lab. Consider the 20-year science study that successfully cloned 58 generations of mice.
58 generations of exact copies. At first glance, that sounds like a massive success for cloning technology.
It was a monumental effort, requiring over 30,000 individual attempts, but it eventually failed. Over those 58 generations, mutations slowly accumulated. Yes, the researchers even observed the complete loss of an entire X chromosome in one line that was never regained, along with various chromosomal deletions and inversions. The biological system simply could not sustain infinite replication.
So the copy of a copy of a copy eventually breaks down. The DNA is like a photocopy that gets slightly blurrier every time you hit print until it is completely illegible.
Precisely. If we tie this back to the broader theme we have been discussing, whether we are talking about cloning biology, AI agents perfectly replicating software code, or building endless data centers in space, you cannot just infinitely copy a complex system without introducing mutations, errors, and degradation.
Yeah.
There is a fundamental friction in the universe that resists perfect endless scaling.
That is a massive insight. You cannot just copy and paste your way to infinity, whether it is a mouse or a code base. The errors always compound eventually.
It forces us to recognize that while our technology is advancing at a blistering pace, with AI taking over screens and nuclear rockets being prepped for Mars, we are still bound by the fundamental laws of physics and biology. The unwritten rules of the universe still apply, no matter how good our silicon gets.
We have covered a lot of ground here. We have traveled from a digital cursor moving on its own on your laptop to companies forcing their human writers to train their AI replacements, right through to antimatter writing in a truck and nuclear engines being built for Mars. It is incredible how interconnected these leaps truly are.
They really are. Every breakthrough in the digital realm immediately demands a corresponding leap in our physical infrastructure.
So I want to leave you with a thought to mull over. If your computer can now drive itself across your screen, and software is perfectly capable of writing its own documentation, what uniquely human friction is left in your job that you actually want to keep? Keep questioning the system, and until next time, this is the Vocal Technologist.
Spoken Tech for your ears.